crowd. Broadcast. Share screen, share, play. Good morning. It is 9 a.m. here in San Francisco. And I know that we will have participants from all over the world. So for some of you, good afternoon. For some of you, good evening. For some of you who are in other continents, good morning also, or good night. I'm very happy to see you all here again at this webinar hosted by Giesen Coffee Roasters and Boot Coffee Campus. We're very happy, and we will have an exciting agenda. And before we continue, I need to take care of one minor administrative aspect here. If you can wait here 1 second. And that gives us also time to look at the connectivity, and it helps you also to be able to get settled. Let me just do this one thing here. So today we will have also, like other webinars, we will have Marcus Young, who is joining us here. Marcus is the campus director here at Boot Coffee Campus. And now we have here been still in a somewhat of a lockdown, like in other parts of the world. Nevertheless, here at Boot Coffee Campus, we do have the ability to do ongoing trials with our roasting profiles and with our awesome Giesen roasters that we have here. Last month, we had the ability to work on various exciting projects related to our work with Giesen. As you probably know, I am the ambassador for Giesen, which really means that I help Giesen do promotion, get the word out, but also work on the quality end. I love doing these trials with the Giesen roasters, understanding what the impact is of a roasting profile on the quality of the coffee. So that's very exciting. And so I just want to make sure that you can all see my screen. So if you could just, maybe one of you or two of you, just give me a confirmation that we're all connected well. I see there's a couple of raised hands. Let me make sure. Okay, perfect. So I see that Eric has said it's good. It seems like we're on a good roll. Great. There's nothing as frustrating as presenting a webinar and thinking that you're doing great, then not being able to communicate what you want to communicate. So today's Giesen webinar, the focus is on two, I would say, basic approaches where it comes to the roasting of coffee. Heat shock versus heat soak. And when it comes to roast profiling, a very common question I get from students and from clients is, where do I start? So how do I determine the benchmark that I'm creating, so that from that benchmark I can prepare unique profiles that set my coffees apart? And that's the focus of today. You can see I have my cap on. This is my Panama hat. It says Best of Panama. I hate being pretentious, but for today I'm making an exception because last night in Panama, the results were published of the Best of Panama, where we have 2 farms that we operate, and we won with our farm Finca Sofia. We won the Best of Panama, first place with the first geisha, second place with the natural geisha, and we also had a very good placement with the worst geisha from Finca La Mula, which is great. By the way, I also want to mention that we have David Satvin, Giesen representative, master technician, colleague, dear colleague here in the US. He is on this call, and he will, I made him panel member, so he will be able to answer specific questions that might come up. Hey, David, how are you doing, buddy?
Hey, good morning. I don't know if you can hear me.
I can hear you, but speak a little bit louder. You're not super clear. How is Pennsylvania today?
It's good. Hot. It's a little bit hot, but it's okay. We'll take it.
Great, cool. Okay, let's get started. So today is myself, Marcus, and we also have David on the line, and for I think our colleague Mark Weber from Europe will be on the call as well, so we can keep him in as well if. And David, if you could put your microphone on mute so that it does not interfere, thank you. And just as a start, in the last webinar we discussed principles of heat transfer. Now, as you know, with Giesen machines, you have excellent control and ability to create profiles using conductive heat, using convection heat, and using radiation heat. Conductive heat is basically heat transfer through contact, from the drum to the bean or from the beans to the beans. Convection heat is heat transfer by preheated air using that medium. And Giesen machines are equipped with very powerful burners and very powerful control on the airflow, which allows the operator to use convection heat at his or her discretion. And then besides conduction and convection heat, there's radiation heat, which is the heat transferred through the materials like the cast iron of the Giesen, which is a unique feature for the Giesen. And when it comes to the profiling options with Giesen roasters, there are basically 5 distinct parameters or 5 distinct instruments that are to our disposal to create profiles. First and for all, we have the ability to set the charge temperature at a specific level, and the higher my charge temperature, the more rigorous the start of my roast will be, or the lower my charge temperature, the more gentle, the slower the profile will get its start. Then secondly, as we covered also during the last webinar, I can use my set point setting. That's the temperature set point. As you can see here on this picture of the panel screen, the set point on this specific picture is at 415 degrees. So I can use that set point by lowering it or increasing it, by doing that by allowing the roast to evolve. A lot of roasters, however, they prefer to not use that parameter, not use set roasting. So they will push it out of the way by increasing it so that it becomes more like a safety cutoff point. And all these temperatures are in Fahrenheit. I know that some of you are metric folks. So since I don't have the ability to quickly convert them here in this webinar, you can easily do this online. 415 degrees Fahrenheit corresponds to somewhere around 200 degrees centigrade.
I'll try to convert in the chat window.
Okay. Marcus is going to convert the Fahrenheit settings or the Fahrenheit numbers into centigrade in the chat window. So you can follow that there. Fahrenheit has the benefit that it's a wider scale, which allows us to be a bit more it's a more precise scale when it comes to roasting, because if you're saying this is 415 degrees Fahrenheit versus 200 degrees centigrade, from 200 degrees centigrade to 201, that's a pretty large jump if you compare that with Fahrenheit. With Fahrenheit, that would be the equivalent of 415 to 417. The other temperature scale that is out there is Kelvin, but I don't know of any roasters that use Kelvin. So that's the charge temperature we discussed. Temperature set point is a good way to potentially control a profile. I personally go by heat supply, and that is through the control of the burner. And I think that's where Giesen roasters are so strong, is that the electronic controls of the heat supply of the burner from 1% to 100% are very precise. So that's a third option for creating profiles. And then, as we discussed during the last month's webinar, we can also use the air pressure. And we actually did some interesting trial with that and a cupping. And that air pressure is displayed through PA, Pascal. And then last but not least, there is the drum rotation speed, the drum RPM. Today, however, we're really going to go for the purpose of heat shock versus heat soak. We're really going to use charge temperature and heat supply as two key parameters. Then, as you know, with the Giesen, we also have this ability to follow during the roast profile the actual rate of rise. And that rate of rise, as we see it here on this panel screen picture, it's just 3.5. The rate of rise is the beam temperature increase per 30 seconds, which is continually calculated. And that's a great way to gauge the progress of your profile. I always say that the rate of rise is like the speedometer in your car. The higher the rate of rise is, the faster you're speeding, the faster you're going through your process. And this is where it comes to using the rate of rise during roasting, it's a great calculation tool. Let's say you are at 300 degrees bean temperature, and your goal is to roast to a lighter roast. Maybe it's 390 degrees bean temperature. So you know that your bean temperature still has 90 degrees Fahrenheit to increase. Then your rate of rise allows you to gauge how many minutes that will take to get there. And so if your rate of rise is 10, which is per 30 seconds, then it's 20 per minute, then it would tell you that to get to 390 degrees from 300, that tells you that it takes about 4.5 minutes at that rate of rise. And so that's a great tool to use as a calculation. So we did for today's webinar, we have done 2 different trials. We used the awesome Giesen roast profiling software for this purpose. On this software, and I'm just showing here a screen picture, because of the glare, the picture is not the best, but you can see in the upper part of this picture, you can see the basic parameters of the roast. You can see here the air temperature is 415 degrees at the moment of taking this picture, the bean temperature 317. The rate of rise was 4.1. The power, which is basically the flame level, the heat output level, 5%. The drum speed, 50 hertz, and the pressure was 120 PA at the moment of the taking of this picture. And what I like about the roast profiling software is that you see the different colors of the graphs, which help you to take quick reference of where you are. On this specific photo, you can see the blue line representing the air temperature, the line under that, the red line, the bean temperature development. And then when we talk about the delta T, the delta temperature, that's the difference between the air temperature and the bean temperature. And you can see this delta T is at the 1 minute mark, it's distinctly apart. It's like 340 to 220, so there's a major difference. And while the roast evolves, the bean temperature starts to approximate more and more the air temperature. I'm going to take a sip of coffee. Cheers. My first cup of coffee of the day. Ooh, that's nice. We were celebrating late to celebrate our success at the Best of Panama. Under the bean temperature, the yellow line, you see the rate of rise. There are these, it has a little bit of a jagged flow. So why is that? I always get questions by students about the fact that this rate of rise is not straight. Part of that is some data distortion. It's the temperature sensors sometimes pick up other information than the information it gets from the coffee. But you can see here in this specific photo around 6 minutes and 30 seconds almost, you can see a little peak. I need to ask Marcus what could have caused that. Sometimes this is simply the cause of the fact that he might have been taking a sample at the 6 minute mark. You can see it comes down. He puts the sample trier back, and then for a brief moment, the thermocouple picks up heat in a different way. That can be a factor. These temperature sensors are very sensitive. And then under that yellow line, you can see the green line. That is basically heat supply, different levels of heat supply. And that's what I really like about this profiling software. It gives you a good reference. We get a lot of questions about whether or not it's possible to incorporate this new software into older Giesen machines. With some of the machines, it is possible. With other machines, it's a little bit more tricky. And so I don't have, unfortunately, I don't have a standard answer on that at this moment. But I recommend that you connect with David Satvin if you're here in the US, or with the Giesen technical help desk to go over that. And for that purpose, we would need, your model number and your serial number of your machine to make that determination. So for today's roasting trial, and we did some work before this webinar, and I think the plan is to do a live roast. Marcus is going to be roasting. So, and I'm just checking in. Marcus, are we pretty well set to do some roasting today? He's in another room, so I cannot hear him, and it's always very tricky when you're in the same space with the interference of the different computers. But he'll be doing a roast with us with this amazing WPGI, which is the sample roaster of Giesen, the gas-fired sample roaster. So now let's look at the conceptual aspect, right? So here we have, this is actually from the Giesen profile. You can export this profile as a PDF so that you can basically evaluate what happens. In this case, this is a heat, let me make sure, yeah, this is a heat soak profile. So first question is, of course, what is heat soak and what is heat shock? So what's the difference, and why would you consider doing a heat soak versus a heat shock? And that, of course, is also a coffee bean question, and it's a flavor question. In all these trials, in order to set benchmarks for your roasting, it's really key to always try to follow a what I call a more scientific approach. What does that mean? A scientific approach basically means is that you, in this case, take the same coffee And that specific coffee, you roast it with approach A, and then you do the same coffee with approach B, and then you cup the results against each other, and you do your due diligence, your temperature, your colors measurements, and all your other measurements that you would want to do accordingly. And that scientific approach then allows you, especially after you do a cupping of that coffee, that allows you to be clear about what the impact of the profile is on the flavor of the coffee. So when I'm doing a heat soak, I'm very gentle with my heat in the initial phase of the roasting. As a result of the heat soak, I also create a rate of rise that is distinctly more gentle than in the case of a heat shock. So in a heat soak, you allow the coffee beans to absorb the heat, initially radiant heat that is absorbed by the roaster. You allow that to transfer to the coffee beans. And in this specific profile where we did a heat soak, we charged the beans at a relatively modest temperature of around 325 degrees. When the profile started recording, that temperature already showed 380 degrees, as you can see here in this display. And as a result of heat soak, you basically allow the beans to absorb heat at the point where the beans start to truly show that this heat absorption results in endothermic heat, which means heat absorbed by the beans. At that point, at the turnaround point where the bean temperature starts going up, that's where you gradually start increasing the heat supply. In the case of the profile that we see here, you can see in the on the green graphic, which is in the lower part of this screen, you can see that for the first minute, this profile started a little bit earlier, but for the first minute and a half, there was no heat supply whatsoever. And then from the first to the second minute, we increased heat to about 40%, and then we increased heat up to 80%, and then to 90%. And then gradually, at the fourth minute, we started to reduce heat again. It's a very gentle way of roasting coffee. So what are the considerations of doing a heat soak? First and for all, that can be related to the density of the coffee. So if the density of the coffee is lower, I would define a high density coffee as a coffee that has a density of more than 65 kilograms per hectoliter. So if a coffee has 70 or 72 or 75 kilograms per hectoliter density, that's a coffee that is dense, that is hard. So if a bean is less than 65 kilograms per hectoliter, then you could generally benefit from doing a heat soak. The second consideration is when a coffee is very fresh harvest and you receive a coffee that you purchased maybe through a direct trade type of deal, it's been a month since it was processed at origin. You get an air shipment of this coffee. It must be a special coffee then. You know, that coffee can still have a relatively high water activity, and doing a heat soak can be really beneficial. And this gets into an interesting but somewhat complicated discussion about how moisture is distributed in the cellular structure of the coffee. But in heat soak, you allow the distribution of that moisture in the cellular structure to even out, to distribute itself before you really start to apply significant levels of heat. And that's where heat soak can work well. A third reason, besides density, fresh crop coffees, a third reason why you might want to consider heat soak, and that if you're dealing with a very overall very delicate coffee. I know coffees from Panama that are just very delicate. Maybe they could be a geisha type. Geishas tend to have the ability to absorb heat easier. Or it could be a Pacamara type, which is a larger bean, or it could be a Maragogipe, or it could be a Mocha type, which is a variety that's very well known in Yemen, or in some other countries they grow Mocha types. So it can be a variety aspect, and specific varieties can create certain bean morphology types that result in the fact that you might want to consider heat soak. So I'm going to come back to this picture to compare it with the heat shock option. This specific profile, which we did just this morning early, here you can see the drying phase. So the drying phase, that is from the start of the roast until the start of the Maillard reaction. That drying phase took around 4 minutes and 35 seconds. And the Maillard phase, which starts somewhere around 260 degrees and goes on till 330, 340 degrees, took about 2 minutes and 24 seconds. And then the development phase, which is the phase from the start of the early start of the first crack to the finish of the roast, took 1 minute and 15 seconds. And that was a 14% development phase. The RD roast development was 14%. The cool part of the Giesen software, as long as you indicate these phases from going on, it gives you this report through a PDF. So if you are roasting, or let me rephrase, let's say you are in a place removed from your roastery and your roast master is performing roasts. You could ask your roast master, hey, send me the PDFs of the profiles of today. And this is a great way to evaluate how things were going. I see there's a question here. Let's see. There's a question from Jordan. When your roaster is showing 0% on your burner, do you have to completely relight at turnaround? I'm not sure what you mean with relight, but you know, with the Giesen, if your flame level is very low, it might show 0%. That means if you're doing a heat soak and your burner shows, are we close to starting?
Yeah, I can move my computer. just took fresh electron readings with the calibrated.
Okay.
I saw that there's electron readings on your slides and they're off.
Oh, okay. Okay. Thank you.
So the circle numbers.
Yeah. So if you're doing a heat soak, your burner can indeed be show 0% at some point, and then at that point you want to start increasing. Salim asks, when you say that you charge with 390 degrees Fahrenheit, do you mean air temperature or bean temperature? Air temperature. So we always talk about air temperature when we charge. Nate asked, what size Giesen were you using for these trials? W6? No, we were actually using the WPG1. Giesen has been very hard to work on consistency from roaster to roaster in terms of how the roaster performs. And so it's pretty amazing how you can translate these profiles from this WPG1 to a bigger roaster. You might still have to do some refinement when you take a profile to the next. I can literally record a profile on my WPG1 and then take it to my W6, which then gives me a great benchmark to continue roasting with my W6. Let me do a few more questions. Okay, no, we already answered these. Great. So we looked at heat soak. So now let's look at heat shock. And my computer, what's going on? Let me restart my screen sharing. So now let's look at heat shock. And so remember the previous roast profile, our rate of rise in the previous profile had a much lower curve than in this case. And so here with the heat shock, my charge temperature was distinctly higher. Previously, we were using 300 to 320 degrees Fahrenheit, and now we literally use 380 degrees Fahrenheit. The temperature that you see here at the 0-minute mark, that's actually when we started recording this profile. You can also see that the green curve in the lower section, we started this roast at about 60% heat output, and we kept it at that level, and then we started tapering down. Why did we use 60%? Because we were using 200 grams in our WPG1, which we have found to be, in terms of a batch, an appropriate batch. If we use 60% heat supply, we typically with this profile are able to complete a roast in about 9 to 10 minutes. But you can see the impact is displayed very much through the rate of rise. And this is where the rate of rise is such a wonderful tool to analyze. I'm just going back in this presentation. Look at the rate of rise that we have here. You can see at the peak of the rate of rise, we were at a little bit over 20. And here we are close to 25. So that means when the rate of rise is at that level, when it's at 25, that means it's 25 degrees per 30 seconds. That means 50 degrees per minute, right? That's a lot. And you have to be very careful to stay at that high point. in this case of this specific roast, we see from the 1.5 minute mark down to 8 minutes, we see that the rate of rise tapered down rapidly. Also, in this case, we see this little flick at the 6.5 minute mark, most likely again, because that's when Marcus took a sample with the sample trier, which created this, dip. And then when he put the sample trier back, it allowed the profile or the rate of rise to go up. And while we're talking, I'm actually tasting from our La Mula. I'm tasting the heat soak versus the heat shock. Very nice. So the difference between the two profiles that we did is higher charge temperature with heat shock. And upon charging with the heat shock, we immediately started to supply heat to the coffee. And as I already mentioned, here we can see the development phase in this heat shock approach was 15%. In the previous one, it was 14%. And the drying phase and the Maillard phase outcomes were fairly similar. So that's the cool part, is here we have a really good comparison between two profiles to the same endpoint, but using two different approaches. And I'm going to explain what I'm tasting so that you can also put this to the test yourself and see if you can come to those same results. Now, as we already mentioned, all profiles always incorporate also the type of bean. For this specific approach, we used Finca La Mula washed, which is a geisha farm I started more than 10 years ago in Panama. It's set up high up on a volcano in a secluded section of the Boquete Valley of Panama. Beautiful place. The moisture was 10.2%. The density was 72 kilograms per hectoliter. And we followed a heat shock as well as a heat soak. I'm actually drinking now the heat shock, and this, it seems like the acidity of the coffee was very well exposed as a result of that approach. It created like this pointed, snappy acidity, like you have in a Cabernet, like in a Sauvignon Blanc white wine, or like you have in apricots when they're not fully ripe, but slightly almost to that ripeness point. And that type of acidity has this snap, and it's also sweet. Another interesting part of these beans are that they're they don't have this open structure as geishas typically have. The La Mula coffees, because they're grown at 1700 to 1800 meters, they're somewhat.
We're now a good half hour in.
And this is actually, I'm going to show you, this is the environment of La Mula.
La Mula is.
Here you can see the unique environment of La Mula. It's like a cloud forest. Our neighbors is El Burro Estate. To get to La Mula, you need to go through kind of a rainforest. And then when you get there, it's a very, very unique environment. And I'll show you the view. This is Leonardo, who is the farm manager. And here you can have a short impression of the trees, bronze tip and green tip geisha. And having said that, I think we can ask Marcus to jump in because I want him to demonstrate a roast profile. Marcus, I should probably promote you first to panel member because I think I forgot to do that. Let me first do that. Okay, so Marcus, now you are a panel member and you should be able to.
All right, hello everybody. Yeah, we are pretty much ready to roast, but I've been tasting these coffees as well, Willem. And, I think for this live trial, what I'd like to do is try to maintain some of that acidity from the kind of more aggressive approach. But I actually prefer the soak coffee because I do think it's kind of more elegant. It's more expressive of fruit. It's not quite as tight with its flavors. So I think if we can try to split the difference a little bit with the higher charge temperature, but still do that soak, maybe we'll come out with something that's really amazing. So.
And Marcus, before you continue, let me just double check. Can everyone see and hear Marcus well? Maybe a couple of you can just confirm. Is Marcus, can you hear him well? Can you see him well? Yes, Eric, thank you. Okay, perfect. Marcus, continue.
Okay, great. So I'll go ahead and share my screen for this roast because I think it will be fun to hit it with the higher charge temperature, try to get that really high initial rate of rise, but still kind of have the benefits of the soak. So I will go ahead and share my screen, Willem, if you enable that for me. And we look at the profile here on my end.
You should be able to share. Okay, make co. Okay. Now you can share, I believe.
All right.
Yeah.
All right, so here is the profiler pretty much ready to go. You can see it's just kind of been bouncing around a little bit, idling from batch to batch. I'm gonna go ahead and just turn my burner off here, and I've got the coffee loaded up, 200 grams of Lamula. And I'm just watching that air temperature. I think when it comes down to 400, with the bean temperature be about 370, we will kick off this roast.
Marcus, we can see you now. Is it possible for you to point your camera to the roaster?
Sure. Let me move this table around.
Okay.
Yeah, so much higher charge temp. How's that on the roaster, everybody?
Perfect.
And now I am playing this profile, so I'm going to have to come in and override it in a few areas. But I think the first thing that I'm going to do is I've already got this higher charge temp coming. You can see my air temperature is much hotter than the reference, and my bean temperature is also coming in hotter. So I just turned on my burner about 15 seconds earlier than in the first profile. With the idea being, let's get this really high early rate of rise, but still try to draw out, kind of that middle phase, that Maillard phase is where we're going to dry it out, but we'll still have that relatively shorter drying time. And I'll go ahead and get my maximum gas up here now. And I am roasting using a combination of manual burner control, but also keeping a relatively low set point so that I'm able to, you can see my set point here is at 415, so that I can still rely on the software to kind of keep me from overheating and really make sure that I slow that roast as I approach and move through first crack to the end of my roast at a much higher rate of rise. I'm going to take this back down to 60% just to leave it there, overriding the recorded profile that I have here. You know, a feature that you can also use with this is when you load up a profile and go to play it, you can actually tell the software to simply use that profile in the background as a visual reference, but give you full manual control. So things are still moving very fast. So I'm gonna just really start coming off my heat already. I have a lot of energy charged into these beans. As Willem said, they are quite dense, the 0.72 grams per milliliter. But you know, these are also coffees. This isn't this year's Fresh Award winning crop. This is some slightly older coffees. So I'm going to override that again. So, you know, being a little bit less aggressive might really benefit me. And here you can already see there, my burner's now at 10%, even though I had my power set at 40. And that's because my air temperature is now reaching and even exceeding my set point. And a very fast drying phase. I'm just starting to see the first color change. As you can see there isn't much green left in the coffee, but I still smell some of that wet, damp grass. So I'm not quite ready to call this color change yet. Here you can see that dip in my rate of rise. That was simply from pulling the trier out. So a very sensitive thermocouple in this WPG1. I'm going to come back to just 20% now on my energy. Really slow this roast down. You can see here now we've kind of entered that Maillard phase. The drying phase has completed. On this again, you can also tell it at what temperature you want to record the end of the drying phase and start recording that sort of midsection of your roast as far as percentage goes. And so here I have it at 163 Celsius, which is about 325 Fahrenheit. You can see it just automatically marked that. So I think now the trick with this roast is going to be to slow it down enough that I don't just race into first crack, and at the same time to have enough energy in my coffee, which I think I will from that high rate of at the beginning, to actually drive those reactions, the evaporation of the moisture in the cells that drive first crack and drive some of those further sugar browning reactions. I'm looking for first crack at around 365 to 370 Fahrenheit. I'm still quite a bit hotter. I'm really gonna just come off this power and just let it coast at 1% now. But be prepared to come back if my rate of rise looks like it's in danger of stalling out. And so this one went a little bit fast, got away from me a little bit. I'm just hearing first crack. I don't know if any of you can hear it, but I will say that this is by far the most dynamic first crack that I'm hearing of all of the trials of this coffee. So by really kind of packing it with energy, it seems to have become quite explosive at this point. And now I'm really watching this rate of rise. I see it dropping. I don't want it to go too low. So I'll give it a little more energy if I need to try to keep it moving forward till the end of my roast. I'm watching my development time and of course smelling my coffee. All right, and I'm going to get the coffee out of here. That looks pretty good. I can save this, of course. Maybe I'll call this aggressive soak, so I can go back and reference that in the future. Yeah, the coffee looks pretty good. I think I was fairly close to my color target. Those other two trials were right at Agtron 69 for the soak, 70 for the more aggressive one. So they were very, very close. I'll stop my share here.
Great. That was cool. Very cool, Marcus. Let me see. I think there are a couple of more questions. Here is a question. What do you suggest to hear the first crack? I use the Giesen W6, but usually cannot hear the first crack. This is, I would say, this is a challenge, not just for Giesen users, but for roasters in general. Roasting machines are often in busy places, either very busy retail places or warehouses where there's a lot of equipment going on. So what I suggest is that you take a reference point based on the bean temperature where you usually can expect the first crack to happen. And once you know where to expect it, it might be easier to hear. I have heard of some roasters using, you know, like a stethoscope to even use that. It really comes down to being able to have a quiet enough place to be able to hear it. But as I mentioned, there are other ways in which you can gauge where you are also in terms of the first crack. And then typically right before the start of the first crack, you typically smell this brief moment where the beans start releasing distinct aroma. And that's that point where at this aromatic release point right before the first crack, that is a precursor for the first crack as well. So I hope that helps. And then Dominic is asking, is there any reason of not changing the speed and the PA in that example? So the drum speed and the air pressure, what I recommend is when you're putting distinct profiles to the test, do not change too many parameters at a time, because that would not allow you to determine which parameter was the important one for the creation of that unique flavor that you create. So change one parameter preferably at a time. If you change all the parameters at the same time, then you will not know in the end what was the key aspect to create this unique profile. And we're basically at the end already. I'm always shocked at how fast time moves in these webinars. If there are no other urgent questions, then I would, before I say goodbye, then I would say the next webinar is on August 31st, which is that correct? Is that the last Friday? It's the last Friday of August. And I'm just not sure if no, it's not August 31st, correction. It's August 28th. So Friday, August 28th. And I will be in Holland then, and I'm going to visit Giesen, of course, and we will be sharing unique information from Giesen, showing you kind of the glance in the kitchen of Giesen, looking at what are some of the unique aspects related to the construction of Giesen roasters, the materials, and I will interview some of their key engineers and some of their key technicians so that we understand a little bit of their philosophy. And it will be an exciting webinar. I wish you all a very successful week. I'm going to have a big party tonight for this reason, for being Best of Panama, because we also won the Panama Cup, which is the prestigious award for being the most successful quality producer of this year. And I hope you will have a great evening or a great continuation of your weekend. And saludos. Thank you. Bye-bye. And Jordan, if you send me your email, and Alonso, if you send us your email, then we will follow up with you through email. Bye-bye.